Okay, so today I wanted to talk with you guys about how to use the chemical structure search within SciFinder. The chemical structure search is exactly what it sounds like. We're going to be able to search by drawing a structure in. In my opinion, it's one of the most useful parts of SciFinder. It's at least it's the option that I use the most, at least in SciFinder. So go ahead and log in. You'll get to your main screen that looks like this. And then on the side here, right, remember these are all the different components, so go ahead and click on chemical structure, and you should start to see this pop up here. And then if we click here, right, it's gonna bring us to another screen where we can draw the structure in that we want to search for. So let's start with something just simple at first, right? We'll go down here to the bottom. We'll click on a benzene ring, and then we'll just click in here. And let's say that we wanted to search for just benzene. Okay. Now on the right hand side, there's a couple different options. There's exact search and substructure search and similarity search. So exact search means it's going to look for exactly this structure right here. No variations really. Okay. Substructure is going to look for any structure that has a benzene ring in it. And similarity search will, I don't know exactly what its algorithm is, but so it kind of works like this. So if we put in benzene, it would hit toluene, right, which is methylbenzene, as a similar structure. So similarity search is not too different of a structure, whereas substructure search means does any structure have this component in there. Hopefully that wasn't too confusing. But as with all these videos, just you can come in here and just play around with it, right? You're not going to break anything. So let's do something ridiculous, right? So here's benzene. We're going to do a substructure search. We hit OK. So we're going to look for any structure that has a benzene ring in there. So let's hit search, and it's going to say there's an error. Structure is way too general, right? So we need to go in and fix this, right? So if you go back up here and click exact structure and then hit search, okay, this should work for us. Okay, now it found 12,000 exact substances. You can kind of see what else it does, right? Since we did not specify what is bound to the carbons, right? Then it says, okay, well, maybe you wanted deuterium, or maybe you wanted benzene with another compound as a mixture, right? Did you want the anion? Did you want the cation, right? So there's, even in the exact substance, there's a couple different variations in there. So what we normally do, well, we'll talk about that in just a minute. So let's keep it simple here. So we search for benzene exactly. Here it is. If you mouse over, you see this blue box surrounds the structure itself. So we'll mouse over, go to the double arrows, and click. And here it gives us a bunch of information, like the CAS number. That's really useful when we want to order a chemical, or if we need to know exactly which chemical we're looking for. Just for argument's sake, write the CAS here, right, 71432. If we go over to this guy here, right, this has a different CAS number, right, so 107643-3, right? So CAS number is assigned for every specific compound that's made, right? So if we click on this, let's say that we wanted to get references or get commercial sources, right? We can see where to order. We could figure out how to synthesize this, although, we would never want to synthesize benzene, right? But up at the top, let's look at this one, View Substance Detail. We'll click on that, and it's going to pop over to this site here, right? So now it gives us a formula, right? It gives us a name, it gives us the molecular weight, it gives us the melting point, it gives us the boiling point, it gives us the density, it gives us alternate names. Nobody calls it that, but I've never heard anybody call it benzol. I don't know, but anyway, right? There's some alternate names in here. If we look down here, there's experimental properties. Let's click on that. Okay, so we have all these different properties that we could look for. And what we really wanted is the acoustic impedance, of course, right? We want to know the acoustic impedance of benzene. I have never I've never even heard of that test being done. Sound velocity, that's fantastic. So let's say that we wanted to figure out about the acoustic impedance of benzene, right? It tells us, take a look in the text, and over here on the right hand side, you see this little 1 in parentheses. This is the reference that this is coming from. So the 1 here refers to the 1 down here, right? So we can click on either one, and um, it'll pop over to the article tab, right? It'll pop over to the article tab that we're pulling in, right? Which gives us an information, what papers were cited, and a little bit of, it'll give us the abstract here. Um, the source for this is the Indian Journal of Pure and Applied Physics. I'll go ahead and tell you we don't have access to that here on campus, so we'd have to order that if we wanted to take a look at this article itself. But it's super cool. I never heard this as a test being done, right? But anyway, if we click, oh, I'm sorry, I might have skipped over that, but I covered it in my previous video, but remember to go back and forth. You can just click on the blue tabs here on the top. If you hit the back button, you lose data sometimes, so if you need to go back and forth from where you were, just click along the top here, right? Experimental spectra, this is really useful. Here we can pull the proton spectrum. Let's see what this will do. Hopefully this is showing up on your screen, but this is this is the NMR spectrum, right? Um, it tells us this is a proton. It tells us where we got this from and the solvent that was used, right? So a lot of information in there too. So that's kind of useful. Let's see what this other spectrum looks like. That one's a lot better, at least a lot darker, right? 400 megahertz NMR, that's nice. You can see the peak sitting in, right? Of course, this peak isn't all that, this isn't all that interesting. This is a completely symmetric molecule, right? We got 6 identical hydrogens on there, so we expect only to see a singlet. We could take a look at the carbon NMR, right? This one's not going to be all, whoa, that's a lot of carbon NMRs, good grief. This isn't going to, be all that interesting either, right? We've only got a single carbon in there, right? But same thing. We could look at IR and the mass spec and the Raman and the UV vis and yeah, I didn't think we got a crystal structure for this right now. That'd be kind of a challenge to do, but that's okay. So we have all this different information here. So if you ever want to really kind of dig down into the molecule and find the NMRs for it or any of the other properties, this is one way to get that done, right? So let's go back to the beginning here. And actually, you know what? This will be a good place to stop the first video, and I'll continue on to the second video about a little bit more about the structure search.